All right. It is popularly said that police is your friend. Okay. Now, also, do you know that PHCN, Power Holding Company of Nigeria, NEPA, they are also your friend. All right. Now, you observe that most of the times, when there is darkness everywhere, and suddenly the light is restored, everybody's shouting, up NEPA, up NEPA, up NEPA. All right. It's a popular slang among Nigerians. Now, you now observe that as the light begins to go dim, you see people shouting, oh, or complaining, oh, now we have low current. Why low current? Or when the brightness of the bulb is so much, so this is high current, high current. Are you sure it is high current? And are you sure it is low current? Now let's analyze your answer using physics. Okay, now, what is the relationship between current and voltage? There was a man that successfully showed us this relationship. The man is called Simeon Ohm. And he successfully showed us this relationship when he gave us the Ohm's law. Ohm's law is a law that shows the relationship between current and voltage. Now, low current, low current, low current. It's a popular slang among Nigerians. Now, but is that correct? Physics says you are not correct. So maybe after this class, we're going to change that slang. All right, now let's see why you're not correct. Now, what's the relationship between current and voltage? Now, simple. In practical terms, current, let's look at physics first. Current is simply the rate of flow of electrons, the rate at which charges flow. So we use charges to talk about electrons. All right, so the rate at which charges flow, current, is given as Q over T. Rate means time. So the rate of flow of electrons or the rate of flow of charges. Voltage. Are we there? The voltage is also called the potential difference. Are we there? Between the terminals of a cell. The potential difference between the terminals of a cell. The potential difference. The difference in potential. The difference in potential. Alright? As regarding a cell. Now, watch. Current and voltage, for instance, like I said, I started by saying, when there's darkness everywhere and suddenly light is restored, what you see is voltage, not current. What brought about the restoration of the light is called current. A practical example is a case of a pregnant woman. Now listen, the woman is pregnant. The proof of pregnancy is that the stomach is protruded. All right, now, the woman's stomach is protruded. So you seeing that woman, all that comes to your mind is this woman is pregnant. Why? There's protrusion of stomach. Though there are some cases where you don't have that much protrusion of stomach, of the woman's stomach. But in most cases, the stomach is protruded. Now, the one you can see, the effect, the resultant effect, the work, the effect of current is called what? Voltage. And Ohm showed us, when he gave us Ohm's law, V is directly proportional to R. What does Ohm's law state? The voltage, V is proportional to I. The current passing through a conductor, a metallic conductor, the current is directly proportional to the what? Applied potential difference between the ends of the cell. The current passing through a metallic conductor is directly proportional to the voltage. Alright? At constant what? Temperature or cross-sectional area. Alright, so we have some factors that are kept constant. We have cross-sectional area that are kept constant. We also have what? Temperature is kept constant. Alright, so then when we remove this variation sign, we have our equal sign. We have R, which is our constant. And R is equal to V over I. Our R is called what? The resistance. And what is resistance? The resistance is simply the measure of opposition to the flow of current in a circuit. So now, current does the work. When light is restored, what travels? Charges. What moves through wires? Charges. You can't see those ones. You can't see charge. You can only feel charges like the anointing. You know, when you go for anointing service in the church and anointing, you understand? You feel it. Okay, you feel the presence of God. Let's lift our hands to worship, all right? So you feel the presence of God, you feel the power of God, the same way you feel current. If you touch a naked wire, what happens to you? You feel the anointing from the wire. The person is electrocuted. That is current. Now, when current moves, the result of the motion of current is what we call voltage. So whenever there's darkness everywhere and all of a sudden light is restored and the bulbs are shining bright, all right, your television is working, every device in your house is working, it is a proof that current has moved, current has passed. So the one you can see is voltage. The one behind the scene is called current. So like the pregnant woman, a protruded stomach is the proof that she is pregnant. You don't know whether she's pregnant with a boy or girl, but you just know that she's pregnant, all right? That proof, the stomach, is voltage. The resultant effect of current is what? Voltage. So next time light is restored in your area and the bulbs are shining so bright, we say what? High voltage. All right? Not high current. Okay? Though they are interrelated, but don't forget that the resultant effect of current, when current moves, the result is called voltage. So I believe I've been able to explain to you the relationship between two of them and the distinction. This is the rate, current, the rate at which charges flow. All right? And voltage is the difference in potential in a circuit. The difference in potential, the difference. You know, a circuit has a battery, and the battery has positive side and negative side. The difference in potential is called the voltage, or also called the potential difference. All right, so don't forget, current is what works behind the scene. The result of current, after working behind the scene, the result of it is what we call voltage. Thank you very much. See you in the next episode.